for section 2.2, trigonometric functions of non-acute angles. Remember that for section 2.1, we dealt only with acute angles. Now we want to start taking what we learned in 2.1 and moving it around to things that are non-acute, like in quadrants 2, 3, or 4, rather than in a triangle or just in quadrant 1. First thing you need to understand is what a reference angle is. Every angle has a reference angle in trig. And that reference angle has all of the same properties and functions exactly the same way trigonometrically as the actual angle. So it depends on what quadrant it is how you find the reference angle. A reference angle has to be positive and it has to be acute. So it has to be less than 90. So if you're in quadrant 1, your reference angle and theta are the same. But if you're not, you have to find it. And so if you're in quadrant 2, this little area here is theta, but the amount trapped along the x-axis here, between the x-axis and the ray, that's theta prime. That is your reference angle. And we'll talk about how to find that. And so we know that when we draw the triangle there, that's the angle in question, but that's not theta. The actual angle is this guy. This is your reference angle. In quadrant 3, we go all the way around here to find theta, but only this piece right here is your reference angle. That's theta prime. And in quadrant 4, theta would be all the way around to here, but this little amount right here, that measure is your reference angle. And your book calls that theta prime, like a little slash mark out beside it, like a minute mark, actually, which is really weird, but that's what they call it. Those are your reference angles, and you know every angle of rotation has a reference angle when you're in the xy plane. And our job today is going to be to find it. So just to be clear, a reference angle is always less than 90, and you always find it by the amount that is trapped between the nearest x-axis and the ray in question. The nearest x-axis. So it's always the one that goes to the x-axis and the ray in question. All right, here's a really common error. I see this all the time. A lot of people find the reference angle by using the terminal side of theta and the y-axis. You can't do that. You want the amount trapped between the x-axis and the ray you're trying to get to. That's going to be your reference angle. You're always in reference to the x-axis, and that's true for all of trig. Okay, so here's our first example. We would like to find the reference angle for an angle of 218 degrees. Well, first off, I need to be able to figure out where it is so that I can start trying to figure out how much is trapped between the x-axis and there. So it's best if you go ahead and you draw it. So 218 degrees would put me over into quadrant 3, correct? Mm-hmm. Okay, so it would be about right here. So there's theta. That's 218 degrees. All the way around to here. I have to go 218 degrees to get here. My reference angle is how much is trapped right here. That's theta prime. I need to know how much that is. Does anybody have any ideas?
Subtract 180.
38.
No,
Yeah, subtract 180.
subtract 180 from,
Why would that work?
because it's the straight.
Because it'll get rid of that entire
What's
top
left.
half.
Right, yeah, it'll take off this part, and then it will leave us with just this part. So if we talk about this as 180 degrees of rotation, okay, I only want the amount trapped in this blue area here. And the way you do that is you just subtract the two. You subtract the mark where you are minus the mark where you're trying to get to. And always bigger minus smaller. So 218 minus 180 is 38 degrees. That's how you find reference angles. And it helps me if I label them, like out to the side. So like if I label this amount and I label the nearest x-axis amount, you know, the closest rotation to the nearest x-axis, and then I just subtract them, bigger minus smaller. Now if you're in quadrant 1, the angle and the reference angle are exactly the same. Every quadrant 1 angle is its own reference angle. Let's try another. Let's find 1,387 degrees. Let's find its reference angle. Well, first off, that's way too big. I don't even know what quadrant that's in. So what do I have to do first?
Subtract 360.
Subtract 360 until I bring it down small enough to find a coterminal angle that is between 0 and 360. So I start with 1,387. We start subtracting 360 off of there,
307.
and we bring it down to
307.
307? Okay. We bring it down to 307 degrees. Now that's not your reference angle. That's a coterminal angle. The reference angle is how far it is from 370 degrees to the nearest x-axis measure. So like if I say, all right, that is 180, 270, 307 is somewhere over here. So all the way around to there is 307. And that's the same as 1,387. I want to know how much is trapped right here. That is going to be my reference angle. The nearest x-axis to 307 has a measure of 360. And so you simply subtract this one and this one, and that will tell you how much is trapped between them. And you want it to be positive, so always do bigger minus smaller. 360 minus 307 is 53 degrees. That is your reference angle. So that means that angle, 1,387, has the same reference angle as 307, which is 53. So all of those angles function the same in terms of sine, cosine, tangent, all of that. The only difference is that 53 degrees would be in quadrant 1, whereas 307 would be in quadrant 4. So you would have to adjust the positives and negatives as you went. But you guys are getting really good at that, at knowing, oh, x is positive, y is negative. Plus we know the ASTC stuff. So once we kind of jump over into that, I think it'll make sense to you. Any questions about that one? You sure? Okay, so how do we find the reference angle? First we bring it down to less than 360. We draw it, we label it, and then we also label the closest x-axis measure. So that's either going to be 0, 180, or 360. And then you subtract the larger from the smaller, and that amount is how much has to be trapped between those two rays. That's your reference angle. All right, so just kind of sum it up. Your book goes through this. I think it's easier to just kind of figure out and not memorize, but I will talk you through it. So your book says, and this is not a really good drawing, I think it's better to go this way. To find reference angles, the first thing you do is get an angle that's between 0 and 360. So if it's bigger than that or if it's negative, you want to find coterminal angles and bring them down between 0 and 360. Okay? Then it depends on your quadrant. If you're in quadrant 1, your reference angle will always equal that angle. If it's in quadrant 1, that's your reference angle. If you look at it and you go, what's the reference angle for 22 degrees? It's 22 degrees. So if it's in quadrant 1, it's its own reference angle. If it's in quadrant 2, the nearest x-axis is going to be 180 degrees. And 180 degrees is going to be bigger than that angle. So you'll say 180 minus theta. If you're in quadrant 3, you're still going to be closest to 180, but theta is going to be bigger than 180. So you would want to say theta minus 180 degrees. And that's how you would find the quadrant 3 reference angle. If you're in quadrant 4, what's your nearest x-axis? 360 degrees. So your reference angle will equal 360 minus the angle you're trying to find the reference angle for. So that's just a quick way. Most people can do that without memorizing it, but if you ever do get confused, you can kind of know that you can memorize it that way, and you'll always be able to find the reference angle. Okay, so here's what we've been building up to. I would like, without a calculator, to find the values of the 6 trig functions for an angle of 210 degrees. If I ask you to do something without a calculator, it probably goes back to the unit circle. But we don't have 210 degrees memorized. We have 30, we have 60, and we have 45 memorized. And then we have all of our quadrantals. 210 isn't on there. But here's the thing. If its reference angle is, then you can still use it. So let's take a look, and the first thing you need to do is find the reference angle. So let's go draw it. So 210 degrees is about right here. Agree? Okay, that's 210 degrees. That's my theta. What is my reference angle?
30.
What is it? 30, yeah. 210 minus 180 is 30. So that's my reference angle. That's theta prime, 30 degrees. We memorized a point to go with 30 degrees. Does anybody remember what it is?
1/2 square root of
Other
3
way.
square root of 3 over 2, comma 1/2.
Square root of 3 over 2, comma 1/2. That's the point that goes with 30 degrees. But I'm not in quadrant 1 anymore. I'm in quadrant what? 3. And in quadrant 3, the x's are and the y's are.
Negative.
So all you have to do is find the point from quadrant 1 that goes with that reference angle, and then adjust the positives and negatives. So if this is the 30 degree point, then the 210 degree point, because it's in quadrant 2, will be negative square root of 3 over 2, negative 1/2. Now you use that point like it is on the unit circle. So that's the thing. This point is on the unit circle. We don't have to memorize it to use it though. Once we can find the reference angle, all we have to do is one of those 3 we already have memorized and adjust the positives and negatives. So this point actually lives right here on the unit circle. And then we can run through very quickly and we can say what sine is. Sine of 210 degrees equals the x or the y? The y over the r. Well, anything over 1 is just itself. So the sine of 210 degrees is negative 1/2. The cosine of 210 degrees is x over r, which in this case is negative square root of 3 over 2. And then tangent. Tangent of 210 is a little trickier. Does anyone remember what the tangent of 30 degrees is? Have y'all memorized that yet? I recommended memorizing it. Look, it's right here. What is it?
1.
The tangent of 30 degrees.
Square root of 3 over 3.
Square root of 3 over 3. If you forget it, you can find it by stacking the y over the x. So the y divided by, and if I divide by a fraction, it's the same as multiplying by the reciprocal. So that is a positive 1 over square root of 3, which is square root of 3 over 3. And sure enough, in quadrant 3, tangent should be positive. So a couple of ways you can do tangent. You can either just memorize it and know that it's square root of 3 over 3 and write it out beside it. And because we're in the 3rd quadrant, that would make it positive, right? Or you can go off to the side and find it each time if you've forgotten it. Then cotangent is the reciprocal of that. Well, what's the reciprocal of 1 over the square root of 3?
Square root of 3.
Just the square root of 3. Or you can go for cotangent and stack x divided by y, which in this case is x divided by negative 1/2 is times negative 2 over 1. Those cancel, and we can see that that's a positive square root of 3. And in quadrant 3, those should be the only two that are positive, tangent and cotangent. Okay, let's try secant. Secant of 210 degrees is going to equal the reciprocal of whom?
Cosine.
Cosine, right? The reciprocal of cosine?
So it's negative 2 square root of 3 over 30.
I don't know. Let's look, okay? All right, so if this is cosine, negative square root of 3 over 2, then secant is the reciprocal of that, negative 2 over the square root of 3, and yes, you are correct. That is negative 2 square root of 3 over 3, because you have to rationalize that. That's where we are so far. One more and we'll take a break. I need cosecant. And cosecant turns out to be the easy one. Cosecant is where we flip sine, right? Well, in this case, negative 1/2 is my sine value. You flip it upside down and you get negative 2. Now remember that the reason this is my sine is because the r value is what? And the r value is 1 for every point on the unit circle, even if it's not in quadrant 1 anymore. If it's moved around to quadrant 3, it is still on there, on that unit circle, and the r value is still 1. Any questions about that? Okay, let's break there.